Hello, everyone. My name is Vishal, and I'm a trainer from Course Approach. And we're going to get started on a new course, a small course, where we'll be going through the um, basic concepts or the foundational concepts, the core concepts of AI, ML, and data science. So we're going to cover a bit of everything. And this is the first part of this small packaged course that we're going to have. And this is Introduction to AI and ML. That's the first session, an intro session. So for this, there are no prerequisites for this session. And anyone can watch this session without having any prior knowledge about AI, ML, or data science, right? Um, so first of all, what are AI? What are AI, ML, deep learning, or data science? What are these concepts? So AI is, if you look at the full form of artificial intelligence, and if you break it down, you have two words. You have artificial and you have intelligence. So here we assume that we humans possess natural intelligence. We humans possess natural intelligence, meaning that a lot of things are inherent for us. So for humans, a lot of things are inherent, which means we have neurons, and even before we are born, we have neurons. And a lot of things are based on evolution. So we have evolved intelligence. Similarly, other living beings also have some sort of an intelligence naturally. It's not artificial. It's not like someone has fed us with that intelligence. Of course, there's always acquired learning that comes on once we are born and later in life, but we are all born with some sort of an intelligence, right? We are born with organs. Each of these organs have roles. Each of our sense organs have roles. We can see, we can smell. All of these form intelligence, and those are inherent to us humans. Those are inherent to us humans. However, those are not inherent to computers or machines. To computers or machines, it's not so obvious. It's not inherent. It's not inherent, or it's not natural, right? And that is why the term artificial intelligence. So it's all about machines mimicking, machines mimicking human intelligence. Or cognitive functions, So when I say cognitive functions, it can mean reasoning, it can mean problem solving, and so on. So machines mimicking human intelligence is called artificial intelligence, right? It's called artificial intelligence. And artificial intelligence has been there since a very, very long time. It's been there for over a century. It's been there for over a century. Just that right now it's gaining popularity. It's gaining popularity right now in today's world, or over the past decade or so, because of the computational capacity we have today. Cloud and developments in computational power or memory has enabled us to build more powerful artificial intelligent artificially intelligent machines and computers. So that's why it's gaining popularity today. So that's about artificial intelligence, right? That's about artificial intelligence. So what I'll do here is I'll just put a big circle here and I'll call this circle artificial intelligence. And artificial intelligence has a bunch of other subfields within it. And the most popular one can be called machine learning. The most popular one is called machine learning. And machine learning is all about you have some data and a machine learns from data that is available to it. From data that is available to it. And in a way, we all learn from data, right? We all learn from data. In our childhood, we learn simple stuff like, how to identify what's a dog, how to identify what's a cat. We learn the alphabet, we learn numbers. And how do we learn? We learn because someone has fed that data into us. Someone has fed all this data into us when we were very young. And similarly, that is how also we train a machine. Just how we were trained when we were younger. Just how we were trained when we were younger to learn from simple data. And when we are older, to learn from complex data. A machine can also learn from simple or complex data. And instead of it learning, we have a set of algorithms that are developed such that the machine can use those algorithms to learn patterns, right? So the machine learns from data that is available to it, enabling it to recognize patterns. And that's what machine learning is. It's what machine learning is. So machine learning will come inside, machine learning will come inside AI. Machine learning will come inside AI. Now, machine learning was further developed into something called deep learning, to something called deep learning. And deep is inspired from depth or complexity. So you can imagine deep learning to be a deeper form of machine learning or a more complex form of machine learning. It's a more complex or deeper form of machine learning. So what that is further, it's a subfield of ML. And this subfield is all about trying to mimic neurons. Trying to mimic neurons that are within us, that are within us. So when we look at a dog, we know it's a dog. When we look at a cat, we know it's a cat. When you look at a cow, we know it's a cow, right? How do we know that? Well, we learned that somehow. Data was fed into us. Our parents kept on feeding some data into us, saying that, okay, when you look at a dog, they kept on saying, that's a dog, say dog. That's a dog, say dog. That's a cat, say cat. That's a cow, say cow. And they used to feed that information to us in different ways, in different languages, right? And each time we used to look at different kinds of dogs, different kinds of cats. And all this together finally came and sat in our head. And now we know what dog is, what a cat is. But that learning itself was a fairly complex process, right? It might sound simple now, but that learning was a complex process because you weren't shown only one dog or one cat. You were shown multiple kinds of dogs. You were shown multiple kinds of cats, multiple kinds of cows in different places, in different backgrounds, in different languages, in different styles. And that is how you learned to identify a cat or a dog or a cow or any animal or any object. And how did that happen? Because that information is stored in our brain, and that storage happens with help of neurons. Whenever we see a dog, there's a reaction in our brain where neurons trigger other neurons. One neuron triggers another neuron, and that neuron triggers a bunch of other neurons, and the message is passed to us saying that, okay, that's a dog, that's a cat. So it's all about neurons. Anything we do, anything we say, anything we think is all about neurons. So what deep learning is it tries to mimic the working of neurons. Isn't that amazing? It tries to mimic neurons. And when you learn about deep learning, you will understand how fascinating it is that we have sort of taught computers or machines to mimic the behavior of neurons, at least how we think neurons behave, at least how we think neurons behave. We have sort of designed a small consciousness consciousness for the computer using deep learning, and it's only getting better and better and better as time passes. And that's about deep learning. And deep learning is all about tasks such as image recognition and speech recognition or speech recognition, speech generation. So anything that tries to mimic things that humans would do exactly in the way that humans would do it is called deep learning. So now deep learning, when I go back to this circle right here, deep learning sort of right here within machine learning. And then there is data science. Then there is data science. Data science is all about using data to extract insights and make predictions using concepts such as statistics, probability, and it uses machine learning. It can use deep learning. It can use domain knowledge. So that's what data science is. That's what data science is. And data science, well, there's a lot of debate on where data science should come within this Venn diagram. There's a lot of debate. Some people will put it over here, some will put it over here, but what I feel is it sort of is like comes over here. So I'll say this is data science. So that means there is a part of data science that is not AI. There is a part of data science that is not AI. There is a part of data science that is not ML or deep learning either, right? So anything that involves prediction is usually within this big circle here. And anything that only involves extracting insights will come outside that circle. That's how I would put it. And when you look at data science, there are so many other things within data science like statistics, probability, so on and so forth. And those are all, they all share an intersection with AI. They all share an intersection. So that I'll put that somewhere around here, but I'll not draw it now because I don't want to make this diagram shabby. It looks nice the way it is currently, right? So that's about the introduction to AI, data science, ML, deep learning, and all these buzzwords you hear about. Now, in machine learning or in AI, you have a few different subsets. Again, in machine learning or deep learning, you have a few different subsets of, well, I would say, subset or a concept. You can call it whatever you want. And I will cover that right now. So let's just call it different kinds of learning, different kinds of learning that machines can be equipped with. I'll call it that. And we can start with something called supervised learning. We can start with something called supervised learning. So what is supervised learning? So supervised learning is models learning from labeled data, from labeled data. So that means you have a fixed input and you have a fixed output. And the output is some combination of the input. So to give you a better example of this, let me say I want to predict house prices. I want to predict house prices. So what I can say is, let's say I have some information like size of the house in square feet. And let's say I have number of floors, and let's say I have number of rooms. And I have price, which is what I would want to predict, which will be my output. These are my inputs. So first what I will do is I'm going to collect some available data already. So there are so many houses out there. I'll sample some houses and I'll collect some data. So let's say I have something like 1200, 2 floors, 3 rooms. Price in crores, let me say. So 1 crore. Then let's say I have this one more 1400 square feet. Let me say 3 floors, 4 rooms. Let's say that costs 1.8 crores. Then let's say there's one more house. Again, 1200 square feet, 1 floor, 2 rooms, and that costs 0.8 crores or 80 lakhs. So let's say I go on collecting data like this for any number of houses, let's say 100 houses. I have this data right now with me. The goal of supervised learning is I want to see how I can combine size, number of floors, and number of rooms. So I'll call this size, floors, and rooms, SFR, and I'll call this P. How I can combine S, F, and R to obtain P. So what I can say is some combination of S, F, and R. So it can be as simple as S plus F plus R is equal to P. It can be as simple as that. But a lot of times, or most of the times, that's not going to make sense because I cannot add these things and to arrive at the price of the house. Like I cannot add 1200 plus 2 plus 3 to arrive at the price. Right? That doesn't make any sense. I need to scale these in some way. And I'm going to add a scaling factor. So some scaling factors. I'm going to multiply each of these with some scaling factors, A, B, and C, to arrive at P. So A multiplied by S plus B multiplied by F plus C multiplied by R is equal to my price. So the whole idea of supervised learning is sort of finding out what the values of A, B, and C are, so that in the future, let us say, I have some house whose size is 2400, which has 2 rooms or which has 2 floors and which has 3 rooms. I know how I can combine these. So this I'll call as present, and this is my future. So now in the present, I have all this data and I know the output. I know the price of the houses also, right? You know the price of your house. If you go to a real estate person, he's going to tell you what's going to be the approximate price of your house, and you know your data, like the size, the number of floors, the number of rooms. You have all this data with you. Similarly, for 100 other houses or 1,000 other houses, this data will be available at present, right? So I'm going to train my model with this data, with these being my features or these being my variables or the inputs and price being my output, so that the model can learn how these inputs can be combined to arrive at my output. And hence, in the future, what I can do, if I don't know the output, if I don't know the output, but I know some of the inputs, like the size, the number of floors, and the number of rooms, I can use this model, which has found A, B, and C, or the scaling factors, to easily obtain the output or the price of the house. So then what I can do, I can multiply A by 2400, B by 2, and C by 3 to arrive at my output or my price of the house. So that is how it works. I learn how I can combine different features or different variables to arrive at the required output. And that is what supervised learning is. That is what supervised learning is all about. So that's about supervised learning. So that's what we call labeled data. So you have some data and you have the label. The label is the price here. The label is the price. And you learn how you can use the inputs to arrive at the label. Then there is something called unsupervised learning. There is something called unsupervised learning. And unsupervised learning is all about finding patterns, finding patterns in unlabeled data, in unlabeled data, in unlabeled data. So what does that mean? What does that mean? Let's say that you have a store. Let's say you have a store. And let's say you have some customer data. You have some customer data. It's customer data. So you have customer ID. You have something called most frequent purchase. And you have something called average purchase amount. You have average purchase amount. And you have something called number of purchases till date. So let's say you have all this data. So I have customer ID A, B, C, D. And A purchases ice creams, B purchases chocolates, C purchases ice creams, D purchases biscuits. Average purchase amount is, let's say, 50 chocolates, 30, 70, 15. Number of purchases till date, 3, 2, 5, 4. Something like this. Okay. So let's say like this, you have so many customers, you have lots of data like this, which is available to you. If you run your own store or any store, or any chain in any country will have this simple information with them, right? And let us say you want to design a marketing campaign. You want to design a marketing campaign or design a promotion campaign where you sort of give customized promotions to customers based on based on historical data. So this is historical data, what you have here, right? It's historical data. And let us say you have designed three types of promotions. And you want to decide based on this data which promotion to give to which customer. And that is what unsupervised learning is. You have this data right here. You have this data right here, and you will decide how you can group these customers into different groups such that the customer within each group will say the customers in each group will share some similarities with each other. So for example, in these four data points, I can create three groups. I can create three groups. I can say group 1, group 2, group 3. And group 1, I can say A and C. Group 2, I can say B. And group 3, I can say D. And you can see my grouping has mostly been based on most frequent purchase. So group 1 is about customers who purchase ice cream most frequently. And both of them have purchased fairly large amounts, 50 and 70, but the other two have purchased less. So this group is based on most frequent purchase and average purchase amount. Group 2, it's B, chocolates, and group 3, it's D, biscuits. So now I know the characteristics of these groups. I know the characteristics of these groups. So I can design promotion campaigns. I can give customized promotion. So now that I know that these groups are there and I know the characteristics of these groups, I can easily say I am going to give ice cream based discounts to group 1, chocolate based discounts to group 2, biscuit based discounts to group 3. Or I can say I will give a slightly, I'm going to give a discount on a slightly more costlier amount, a slightly costlier product for group A and C because they have purchased for a higher amount, and less costlier for B, and least costly, costly for group D or group 3 because the average purchase amount is only 15. So this is all about unsupervised learning. So you train a computer or a machine to intelligently group data, such that you can then use those groups for some other purpose, for any purpose. That's about unsupervised learning. It's about unsupervised learning. Next, you have something called semi-supervised learning. I'm not going to go too much into detail about semi-supervised learning, but here you have some labeled data and some unlabeled data. And you combine these two to teach some task. Teach some task to a machine. So you'll not always have labeled data, right? You'll not always have labeled data. Sometimes you might not know the price of so many houses. You will just look at the houses. For some of them, you know the price. For some of you don't know the price. But you want to combine those two kinds of data for some reason and then get some insights. So that is what semi-supervised learning will help you do. It doesn't depend on only labeled data. That's about semi-supervised learning. Then there is also something called reinforcement learning. Reinforcement learning can be combined with deep learning, machine learning, statistics, any kind of AI-based concept. And that's about machines learning with help of feedback from the environment. So for example, let's say I am playing a quiz. I'm playing a quiz. And playing a quiz is all about, starts with easy, then goes to medium, then hard, then very hard. So I have a set of questions like this. Let's say the computer first throws a medium level question. Medium level question. And let's say I get it wrong. If I get it wrong, what question, what level question should the computer recommend next? If I get it right, what level question should the computer recommend next? Let's say the next question is based on my response. My next question is easy. And let's say I get that right. So should the computer recommend a medium or a hard? So these kinds of decisions based on feedback. So here the feedback is my response. The feedback is my response. So I'll say feedback in this case is the response, each question. And based on that feedback, it's going to decide what question to give me next. And that is how reinforcement learning works, mostly used in games, in robotics, and so on. So that sort of talks about the different kinds of learning, different ways in which a machine or a computer can be learned, or in which we can teach machines. And if you think about the real world applications of real world applications, AI or ML, there are just so many. There are just so many. And I think I'm most fascinated about the applications in healthcare applications. And AI ML is already being used in diagnosing cancer, fractures, diseases, using scans. Computers can already do a better job in recognizing or in diagnosing lots of diseases. I've been reading that these multimodal LLMs out there like ChatGPT can already diagnose fractures better than doctors can, or better than radiologists can. And how these are done is the same way. You have labeled data. You have so many scans out there. Like you have so many scans out there. So you have a scan and you have the output. So let us say this scan indicates bone cancer. This scan indicates skin cancer. This scan indicates no cancer. Again, there's another scan which indicates skin cancer. So you have the input, which is the scan, you have the output, and you train the model. You teach the model how it can actually go inside the image and find patterns within the image, patterns within the image which indicate these cancers. So that later when I pass an image, and I don't know what is the problem or what kind of cancer or whether the person has any cancer or not, it will tell me what kind of cancer or whether the person is cancerous or not. Right? It's used in drug discovery, it's used in predicting patient outcomes. If you have it's even used to predict the life expectancy of a person. So you have those things like drug discovery. This can be using statistics as well. And you have predicting outcomes, or you can also call that prognosis. That is about healthcare. And then you have retail. And a bunch of other use cases in retail, like you have recommendation systems. So that means you can go to Amazon right now, Amazon.in or Amazon.com right now. And as soon as you log in, you're going to see a bunch of products that are recommended to you. And those are based on your historical purchases, And that is using machine learning or AI driven recommendations. So it is some combination of your historical purchases. Your recommendation is some combination of your historical purchases. So you have recommendation systems, then you have demand forecasting. So if Amazon made $10 million of profit last month, how much profit is it going to make this month? If it made $100 million profit in the past 6 months, how much profit is it going to make in the next 6 months? Those kinds of problems. And again, we just saw an example of how you can use it to design marketing campaigns or promotional campaigns, right? And one more field which, in which the use cases of AI ML fascinates me is finance. So you have algorithmic trading, in which you don't even need a human. You teach the computer how to trade. Teach the computer how to trade. You have fraud detection. So banks use fraud detection when credit cards use fraud detection, where a transaction is made, and based on some information about the transaction, you decide whether it's a fraudulent one or not a fraudulent one. And if it's a fraudulent one, you reject that transaction. So sometimes you see your transaction might be rejected because it might be that the website to which you're making the transaction may be a fraudulent website. So the credit card company may decide to reject your transaction. So that's using AI again, AI or ML. And you have credit scoring. So your credit scores can also be based on some machine learning algorithm. And I can go on and on and on. AI ML is used in um, so many things: weather, climate, weather forecasts, climate change predictions, in manufacturing, like for example, predictive maintenance. Um, Transport, especially these days, you are using it heavily in autonomous vehicles and even daily life. We use it every day. We use AI every day. ChatGPT, which is an LLM, multimodal models. And if you think about it, you yourself, you can think about yourself as the way you think is also algorithmic. So there is an algorithm behind how you think and why you think something. Um, we will see, we will see that in the future sessions. Or if you want to take a class with me, um, I can make it super intuitive for you about how deep learning is so related to how we think, or how machine learning is so related to how we think. You will be surprised. You will be surprised, right? So that covers, a lot about the introduction to artificial intelligence and machine learning. So we looked at the definitions of AI, ML, DLDS, how they are related to each other. We looked at the different kinds of learning, which are supervised learning. You have unsupervised learning, you have semi-supervised learning, you have reinforcement learning. We looked at examples for each of those. And I think supervised learning example, you sort of see how you can scale the inputs to obtain some output, so that in the future, when you don't know the output, you know how to scale the inputs that you know, so you can obtain the output. Then unsupervised learning, how you can design promotional campaign or a marketing campaign to customers to your store. We learned about semi-supervised learning. Of course, I didn't go too much into detail. Can get a little complex, but we can always have a class about semi-supervised learning. And then there's reinforcement learning. I gave you an example for that as well. And then the most fascinating real-world applications of AI and ML. So as we move forward, in the upcoming sessions, the plan is we are going to look a bit into each of these different types of learning, like supervised learning, unsupervised learning. Mostly these two. We're going to get a peek into these two types of learning. We're going to look at essential statistics, essential math and stats for AI/ML, for AI and ML, because you cannot go into the depths of ML or DL or DS without math and statistics. You can learn a bunch of things without math and statistics, but if you want to go out there and you want to build your own models, if you want to go out there and build your own models or build your own high quality models, then you must know some essential math and statistics, because that's the foundation of AI/ML. But there are some things like Gen AI, which you can learn with minimal math and stats, with minimal math and stats also. So with that, I'm going to end today's session. I hope you all had a fun time. And once again, my name is Vishal. I'm from Course Approach, and I'll see you soon in the next session where we'll be digging deeper into the different kinds of learning, supervised, unsupervised, and we'll also get a sneak peek into the math, the stats. We look into Gen AI, NLP. We'll look at a bit of everything in this packaged course. Hope you enjoy this session. Thank you.
Thanks for watching. Please check out the description for live sessions if you're looking for, and also visit our website Course Approach for full details and next steps. See you there. Thank you.